Alright everybody, thanks for joining me. Today we're going to be multiplying and dividing, and we're going to focus mostly on the basics and then get a little bit more complicated here. You're also going to find some powers here, like example 4, negative 5 to the second power, and that's brought up because it is the same as multiplication. Powers are just repeated multiplication. It's not that big of a deal. So, usually they're included initially in a section like this. All right, so we start with example 1 here. We've got 3 times negative 8. You're going to see this a number of different ways. Sometimes you would see it like this. It doesn't really matter. When the two numbers are pressed next to each other, it means you're multiplying, so no matter how you slice it, you should get negative 24. A positive times a negative is a negative. Meanwhile, on example number 2, a negative times a negative becomes a positive. So I think those are things you know pretty well. When you get to example number 3, if you don't have a calculator convenient and you want to go old school here and line it up, and 5 times 7 is 35, carry the 3. I mean, that's all fine and good. 1 times 7 is 7, plus 3 is 10. I don't really care how you approach it. The reality is 9 times out of 10 you're going to have a calculator lying around, but it's still good to know just what's going on, because I have dealt with tests in the past where a calculator wasn't allowed, and you would hate to be in that situation and not know what's going on. All right, like I said about powers, negative 5 to the second power. That just means you're going to take the number negative 5 and multiply it by itself. So you're going to write the number negative 5 twice because it was a second power. If it was a third power or a fourth power, you'd have to write it 3 times, 4 times. Now, the reason a lot of people get this one wrong, the answer is 25, because you had a negative and you had to use the negative twice. It was negative 5 multiplied by negative 5. Now, the interesting thing is, and I didn't include it here, but you do need to know, that would not be the same as if it was written like this. If the negative sign were not in parentheses, then according to our order of operations, exponents would have to come first, and then you would bring the negative down in the end. So this and this are not the same. So I like throwing that in there because that's one that I can stump just about anybody with at any level, because it's something that people don't think about. All right, example number 5, 6 divided by negative 2. Same rules apply as far as signs are concerned. You're going to divide 6 by 2. You're going to get 3. And then a positive divided by a negative is a negative. There you go. All right, negative 4 divided by negative 8. So now you're going to end up with a positive answer because a negative divided by a negative is a positive. And 4 over 8, if you just write it like that, you'll probably remember, wait a second, 4 out of 8 is the same as 1/2. Turns out your final answer is 1/2. This is going to be a matter of opinion for teachers as far as how they want it written. Do they want a fraction? Do they want a decimal? That sort of thing. My general rule is if your initial problem has a decimal in it, your final answer should probably also be written as a decimal. For me, consistency is important. But ultimately, you need to make sure you're following directions and that whatever is being told to you is what you go with. All right. So we've got negative 150 divided by 10. This is one of those tricks where if you learn from the past, you can take off the zeros. Now, this is a bad habit that sometimes people get into. They don't really know why. That is true, but they don't really know why. I think the habits sometimes develop when we just sort of go with something and we're not really sure why we do it, because eventually we start using it at the wrong times. The reason that trick worked, the reason the answer to this problem is negative 15, is because what we've done here, we just divided the top by 10 and the bottom by 10. So we reduced the fraction by 10. Anytime we knock off a 0 like that, that's basically what just happened. Okay. All right, example number 8, we've got 0.42, and we're going to multiply it by negative 5. Now, we know that a positive times a negative is going to be a negative. So when it's all said and done here, we can just go through it as if it's a regular 5, and then when it's done, make it negative. All right, so our answer is negative 210, right? Maybe not. We forgot the decimal. Because we had 2 decimal places right here, 1, 2, that means when we do our final answer, we need to make 2 decimal places in it as well, 1, 2. So that means the decimal is going to go in between the 2 and the 1. So that's going to put us at negative 2.8. 1. All right, now when we get to this division process here, if you want to treat it like a fraction, you could. There's nothing wrong with that. If you forgot the decimal rules for division, it's sort of the same thing as what we did before with eliminating the zeros, only instead of dividing the top and bottom by 10, we're going to multiply the top and the bottom by 10. And what I mean by that is you are allowed to rewrite this as 17.2 divided by 4. We move the decimal over one place on the inside of the division symbol, and we move the decimal by one place on the outside of the division symbol. That is allowed. It's the same thing as multiplying both numbers by 10. So if you feel like doing it, that's totally fine. And then you bring the decimal straight up when you're done, and you end up getting 4.3. Now, again, my general rule is if your problem started as a decimal, it should end as a decimal. And if your problem starts as a fraction, it should probably end as a fraction. For me, it's all about just being consistent. All right, example number 10 here. You could treat it like a division problem. You could treat it like a fraction. There are a lot of different ways to do it. Let me show you what you would do if you were treating this like a fraction instead. And again, you're going to have a lot of different ways you can approach this. If I set this problem up as a fraction, I would then look at the decimals and I would say, wait a second, I could multiply the top and the bottom each by 10. That would move each decimal over by one place, and I would get negative 36 divided by 9. And that was really convenient because now I look at that and I know that the answer is going to be negative 4. All right, example 11. I know we've got a lot of examples here, but it's because they're going pretty quick. When you do something to a third power, that means you're going to multiply it by itself 3 times. Now, I don't want to bore you with that process, so I'll just start it here. You've got 1.21 if you multiply the first time around. And then you're going to have to multiply by another 1.1. So 1.21 times 1.1 should get you 1.331, I hope. All right. Example number 12. Oh, I like this one. This one's important. I need to make a little note here. This is an example of the inverse property of multiplication. And you might be looking at that and you might just be saying, hey, wait a second, I thought we were doing this multiplication and division part. I thought we were done with the properties. Well, we're never really going to be done with the properties. In this particular textbook, they bring the inverse property up in this lesson because whenever you multiply something in such a way that it becomes 1, as in 2 over 7 times 7 over 2, if you were to multiply straight across, you'd get 14 over 14. Now, some of you might notice, well, we could just cancel the 2's and cancel the 7's because my 6th grade teacher taught me so. That's true. The answer is 1. There's nothing wrong with doing it that way. But I'm bringing this problem up because we're talking about the inverse property of multiplication here, as in if you multiply a number by another number and it turns into a 1, then you just used the inverse property. You just found the number that would be required to take your original and turn it into a 1. All right, so it's a big deal. It comes up quite a bit, and normally in the past I've brought it up with all the other properties at once, but in this particular textbook I'm working off of, they save it for this particular lesson, and that's okay with me. All right, now when you divide fractions, what you're really doing is just multiplying by the reciprocal. It's not that exciting. All you have to do is just flip the number that you're dividing by. That's a key. You have to divide the second one, which means you are flipping the second fraction, and then you're turning this into a multiplication problem, which if you just go straight across, that would give you 6 over 36, and then you could reduce it, and it would become 1 over 6. I'm kind of running out of room here because there's a lot going on, but you should get 1 out of 6. Now, if you would have reduced earlier on, you would have still gotten the same answer. If you would have taken the 2 and the 4 and called it 1/2, you got a 1 and 2. Those tricks that you learned back in the day about cross canceling, those tricks are still valid. So if you know them, go with them. All right. Let's try this again. Here we are dividing. That means we're going to take the second fraction and we are going to flip it and we are going to multiply. And that should give me negative 9 over 20. Now, it doesn't really matter if you put the negative sign on top or in front. That's just going to be another teacher preference. I generally would accept either way if it were me and I were grading paper. So you can either leave it there, you can leave it on top. It's all good. It doesn't really make a difference to me. All right, last but not least, if you have an integer such as negative 2 and you are multiplying it, it sometimes helps people to put it over 1. That way they remember that when you go straight across, you're going to get negative 18 over 4, and then when you reduce it, you get negative 9 over 2. That helps some people. Maybe it would help you as well. All right, thanks for joining me. I appreciate your time. Good luck the rest of the way.